For this question, we have a recessive autosomal disorder, so that means this is not sex-linked, and we're told that there's two individuals, they're both carriers of this disorder, and then we have a question about the probability that various children will be affected. So the first thing to note here is that when you have carriers, carriers are going to be heterozygous. And the reason for that is because they do carry the allele that actually causes the disorder, sickle cell anemia in this case, but they're not affected. So since they're not affected, we know that they have to have a capital or dominant allele as well. So we've got two parents like that. So I'm going to write that right here. And then we want to know if they have 4 children, what is the probability that one child is going to be affected and the other 3 are not? One thing to note here is that there is no order specified. So since there's no order specified, we have to consider that that affected child could be the first child, it could be the second child, third child, and so on. So what we want to do first of all is write all the different orders that this could actually happen in. So I'm going to just use an A to represent affected, and I'm going to use an N to represent the children that are not affected. So we could have the first one affected, the second child not, the third child not, the fourth child not. That would be one order. We could have it where the second child was the one that was affected, and then the third and the fourth are not affected. Another order would be that it could be the third child that's affected. And then just a fourth order that this could actually occur in, we could have the last one be the child that is affected. So all 4 of those orders that I've listed are things that would fulfill what we're looking for here. So all of them represent 4 children, 1 child's affected, 3 children are not affected. So to solve this, what we want to do is we want to first calculate the probability of each one of these orders. So I'm going to look at just the first one starting out. And so I want to know with these 2 parents, okay, so the 2 heterozygous parents, I want to know what is the probability that that first child will be affected. So to figure this out, I'm going to draw a Punnett square for these 2 parents. So here's my Punnett square. And when I draw this Punnett square, notice that this bottom box here, little a, that would be the child that is affected. So the probability that that first one is going to be affected is going to be 1/4, 1 out of 4. Then I want to know for this second child, which is an independent event, what's the probability that it will be not affected? So same parents, same cross, we can use this Punnett square here. So in this case, notice that 3 out of the 4 boxes are not affected. So for my second child, I'm going to write it here. The first one was 1/4. The second child is going to be 3/4. That it's not affected. Then I want to figure out for the third child what the probability is. That one, again, if we look at our square, we can see 3 out of the 4 boxes are not affected. So I'm going to have 3/4 for that one. And then for the fourth child, since I'm again looking for one that's not affected, that one is also going to be 3/4. So if I want to figure out the probability, the overall probability of that particular order, so we'll say order number 1, the probability for order number 1 is going to be all of these multiplied together because each child is an independent event. So if we go through and we multiply all of those together, we multiply straight across the top, which is going to be 27, and then we'll multiply straight across the bottom, which is going to give us 256. Okay, so 27 over 256 would be the probability of order number 1. Now we want to go through and do this for each one of these different orders. So if we went through for order number 2, we would do the same thing. We would look at the probability in this case of the first one being not affected, which again, if you look at your Punnett square, this is going to be 3/4. The probability that that second one is going to be affected is going to be 1/4 because again, we're looking at this one here. The probability the third one will be not affected is 3/4, and the fourth one not affected is going to be 3/4. And if you go through and you multiply all of those, we're going to get the same thing, which is going to be 27 over 256. Do the same thing for order number 3. This one you would have basically 3/4 times 3/4 times 1/4 times 3/4. Going to end up being the same thing again. And then for the very last one, order number 4, we would have 3/4 times 3/4 times 3/4 times 1/4. And again, when you put all that together, we're going to get 27 over the 256. Okay, so once we've done that, we're almost done. We've got the individual probabilities of each one of these orders. But if we go back here, since no order is specified, it could happen this way here, or this way, or this way, or this way. And so this is the OR rule that we're going to use, which is the addition rule. Okay, so we want to use addition of these individual probabilities to come up with the overall probability. So in that case, we're going to take each one of these 27s over 256. We're going to add all 4 of them together to get an overall probability. So when we do that, we're going to get 108 over 256. And then that does reduce down some, so you would want to reduce it down. So if we reduce this down, it can be divided by 4. And when we divide it by 4, we're going to get 27 over 64. Okay, so 27 over 64 would be the answer for this one. So that tells us the probability that if they have 4 children, 1 child is going to be affected while the other 3 are not affected.